We already guided media. Let's go to the unguided media. In under this unguided media, we transmit the signal from one source to the another location by using the uh, unware. Okay, by using air-to-air communication. In unguided media, air is the medium. Okay, no physical connections. We are sorry. We are having the air medium. So how to transmit the signal in the air? That we can do using the electromagnetic energy. Using the electromagnetic energy, let's see that the so in this electromagnetism, that it can travels the magnetic wave. We cannot we know that magnetics, okay, magnets we can have north pole and south pole. We cannot see the physical structure of the magnets, okay, how it's working. We cannot see the physical content or physical element of the magnet, okay, but it execute that if there's one element, metals or anything, it's magnetized. That if you keep unmagnetized element, metals or metal chips, then you can see the the execution of this magnetism, okay. So what is the use of those magnetic wave? Let's see here. We have magnetic wave. So those waves are classified in the form of hertz, okay, frequency. How many wave can travel in a seconds? Okay, a cycle. There are different types of wave, like a radio wave, X-ray, microwave, IR, infrared wave, and like different types of ultrasound, ultrasonic. All these things are comes under this wave. Okay, that's let me I'll explain this in this form. Different types of waves. Okay. Okay, let's move on to the next point. Unguided transmission broadly classified into three categories. Radio waves. Okay, but let's move on first to the radio wave. Radio waves are the electromagnetic wave. So magnetic is the base. Okay, electromagnetism. Electromagnetic wave that are transmitted in all the directions of the free space. So we have a free space, air, that travels the electromagnetic wave. In the free space, it can travel the electromagnetic wave. Okay. Radio wave are omnidirectional. What is the meaning of omnidirectional? We have different types of uh, spreading the electromagnetic wave. Directional is there, only one directions. We can spot at the directions. Let's see here. Directional uh, directional directional radio antenna. Okay. These directional radio wave transmitted in single wave beams. Okay, single line beam. Single wave. Only one directional. If we say this omnidirectional wave, we can say this 360 wave. Okay, these are the difference, omnidirectional and directional. So radio waves are omnidirectionals. Okay, it is not directional. This is omni 360 degree. The signal are propagated in all the direction. The range in frequency of radio waves is from 3 kilohertz to 1 kilohertz. Okay, 3 to 1 kilohertz. I already explained that what is the unit measurement of the frequency. This is hertz. Maybe in the form of kilo, or maybe in the form of mega, or maybe in the form of giga. Okay. In the case of a radio wave, the sending and receiving antenna are aligned. The waves sent by the sending antenna by the receiving antenna. So we need to have the antenna to transmit the radio wave, electromagnetic wave, travel in two directions, directional or omnidirectional, based on the antenna. Then the receiver receives these informations using the receiving antenna. Okay. And the example of the radio waves is the FM radio, AM radio, or any other things. Here, let's see the antenna of radio wave. Here we have a antenna in the ground propagations. So we can have three types of propagations: ground propagations and space propagations and satellite. Okay. Satellite also called, we can have space propagation. Sorry. In the ground propagations, it can travel the electromagnetic wave or a radio wave on the ground. ถ้ามีกันเลยฟูหลายเห็นข้าง ground propagation นั่นที่เขาสุกลเทนี่ example ละให้ FM กันติเต AM กันติเต short wave กันติเตเขาเตเนาะ radio station นั่นจังอันนั้น transmit แรงground propagation นั่นตา satellite เตะขันไปนะฟังเลี้ยงกันติพัน omnidirectional manga antenna arong thon chuaka kan le hul arong kalme chu chu kan FM radio kan allow receive mai ta ne radio kan chumi ro receive to chuan enge ti nge ngai kan ti chuan the transmitter transmitted in a particular frequency ka chu chiang mai mo atin 900.7 te 93.5 kan ti te mo kaka a frequency ti 93.5 megahertz kan ti chuan kami 93.5 megahertz 100.7 megahertz kan ti chuan 100.7 megahertz a kana transmit ta ngai ni chumi ni lo chuanin radio transmission ka FM ka buai nui me doni heta 93.5 le 100.7 and subway no it will collide. So we needed to have a registered and the power of transmission to the government of India under the authorization under the authority of this radio communication. So we cannot transmit any frequency from our stations. We need it's a regularized frequency. How much power we are going to transmit. Power also very important in the radio transmissions. If we are mapped with the frequency, okay, if we are mapped with the frequency, that frequency is the unit measurement of the cycle per seconds, we can say. But the distance of traveling this frequency is measured in terms of the power. If your power is very less, then there is no there is no coverage in this communication. So we need to have power. Okay, that in the radio, India radio, Red FM, all these things, they have a transmitting power of megawatts. Okay, megawatts of powers. So it can cover air cover around a 20-kilometer range or maybe a 50 kilometers. So that power is very important. So in our toys also, they have their own walkie-talkie FM radio communications, but it's used only the AAA pencil battery only. So we cannot expect the far communications. Okay, this is it can communicate with the short communication only. A battery power katle ne mawangin thui tak in communicate na tan chon kan base phalo shim ane. Amar chuka ka radio communication chui thawani electromagnetic wave athon chuak ve an receive the ya frequency mangkhan pro. Let's compare with the radio communications. In the radio communications, we have high powers, then it transmits in a particular frequency. This particular frequency is a regularized frequency. We cannot transmit our own frequencies. Okay, kaya mani duak angin kan du frequency ha kan transmit no telo. Dan panga permission ne thlapa transmit angai thina ni kan power pack za to te po enki makha I dani na min pack thlapa ngai permission kan lak thlapa ngai ani lo chon midang communication kan ti boy the chan chu radio ni ta wangin wireless I ta wang khan mo chumi ani awang chuan hemi enge ni ke mani station na po kan lo receive na po khan kha frequency kalo receive to so we have to tune our frequency ani taro we have to tune our frequency like 100.7 we want to listen this FM Zoe then you have to tune it to 100.7 then if you want to listen this Red FM 93.5 then you have to tune it your frequency so you receive the channel from this. Okay, this is the ground propagations. Okay, ground propagations, this earth surface. But if we say there's a space propagations means in our earth atmosphere we have different types of layers are there. Okay, ionospheres, mesospheres. Okay, there's lots of atmosphere we are having. This is the lower part of this atmosphere. Okay, if you search the Google, then you can see the different types of layer. In the ionosphere, this is the mixtures of ions and gases and all these things. So if you transmit the radio signals to the ions out to the atmosphere, then this ionosphere reflected back those radio signals to the earth. So it can use for transmitting this radio signals. Okay, it's reflected back to the signals. This is called the space propagation. Satellite also there. Satellite, it can transmit it. It's sent out to the uh, outside atmosphere, and the satellite receive these informations and return it back. This is the one of these wireless communications. Okay, let's move on to the applications of the radio wave. Radio waves is useful for multicasting when there is one senders and many receivers. A radio wave televisions, cordless phones are example of the radio waves. Very simple. Advantage of the radio wave is the N is mainly used by the wide area network and mobile cellular, and radio waves cover large area. They can penetrate the wall, and they can penetrate the wall. Radio waves provide higher transmission rates. Okay, then the cellular phones and all these things, radio waves also used in the mobile phones and other this radio communication, radio station, and also it transmit and provide higher transmission rate and all these things. So it can penetrate walls due to the low frequency. Okay. Okay, these are the things in the radio waves. Let's move on to the microwaves. Microwaves are of two types, terrestrial and satellite microwaves are there. And then what is the terrestrial microwave? Terrestrial microwave, we can have a antenna in the terrestrial microwave. Let's see in this Google. Let's see in the graphics. What is the terrestrial microwaves? Okay, this is the types of the terrestrial microwave. So microwave transmitted the signals in a very high frequency. If the signal is very high, then it cannot penetrate the wall or the mountain or buildings. Okay, this is the terrestrial microwave. Okay, so we have the sender and receiver, repeaters, all these things. So to transmit the radio communications, sorry. If we want to transmit the data from one source to the locations from Aizawl to Guwahati, then using terrestrial. In between this, we needed to set up lots of tower, antenna, repeater, and all these things. Okay. And from Aizawl, from India to UK or the Middle East, we need to set up lots of antenna. Or to cover the Asia country, then we need to cover lots of. We need to set up lots of stations. Okay, towers and the repeaters and all these things. So it's create lots of problem in the terrestrial. There's lots of mountain buildings, and due to the curvature of the earth, then we can transmit the signals. It cannot travels in a curve. This terrestrial microwave is the line of sight communications, we can say. It should be a line of sight. It cannot bend. Okay, so it should be line of sight. In between this, if there is some obstacle, mountain or building or tree or anything, then